If I tell you that I have reached the optimum level of weight, and I'm now 80 kilograms, and I would like to make sure that I achieve stability at this level. So I don't want my weight to deteriorate later on, either up or down. I need to make sure that my weight is stable. Okay, then I tell you, I will. I'm sitting on the scale every day and checking my weight, and today I found it to be 80.1, and then in the day after, I got it to be 79.9. Right? You will tell me, okay, you're in a stable mood, just small fluctuations. That's normal. Maybe because you have some water in your body, something like this. You did not exercise just yesterday, but overall you're stable. Okay, so I kept um, weighing myself, and after some time I found my weight to be suddenly to be 1882. Okay, then you'll tell me, no, there is something wrong going here, right? And you need to make sure that you what went wrong, and you need to find out what went wrong to get back to your stability again. Okay, to 80. So this is one way of thinking uh, about it and about stability. So there is a level after which we start telling ourselves, no, this is too much, right? And also it can happen that you tell me, like I tell you, that the weight was 80, then after the second, after the I did the weighing again, and it was 80.1, and then 80.2, and then 80.3, and 80.4. Then you'll tell me, no, stop. Even though that you did not reach like 82, it seems that you have a upward trend, and you're doing something wrong, and you need to take an action right now. Okay, so how exactly should we decide, or what are the key rules by which we can decide that there is instability in the process or in the performance, and how to identify those instabilities when they happen, so that we take action only when necessary? Okay, this is what the control charts will achieve for us, and this is the topic of the next video.
Let's have a look at this histogram based on data for synthetic resin parts collected 5 times a day. So here to the left, you can see a histogram that displays the frequency for different uh, ranges or observations found for each of the classes. Using this data, a graph was drawn indicating the average daily values x and the daily range r. It was drawn in the same way that we're familiar with, which is the line chart, um, um, the ordinary broken line graph. This graph shows that the values were low in the beginning, and then it showed a tendency to rise over time. We could not have learned that fact just by looking at the histogram, right? So here we have a time factor that shows us that we have an upward trend, right? We were able to obtain new information by looking at the movement of the data. The role of the group leader is to be fully aware of the characteristics within his authority and take measures immediately um, once detected any abnormality. In this case, in order to carry out the duties effectively, it's most important to take control, to make control charts by constituting these sub groups in this way, so that it's easy to um, draw and then later on interpret the data. Okay, This upward trend might or might not be an indication of something good or something bad, right? Because if referring again to the weight example, maybe all of these observations or all of these movements, including the trend, may be within a stable limit. So it's within a limit that is very natural and that it's expected to happen, and there is nothing wrong with the observations. So the challenge here, or the next step here, would to draw control limits that will show us whether this process is stable or not. So the problem here is to find out whether the points on the graphs are abnormal or not. For example, in the first 4 points of X might be normal or below normal. Thus, when the standards of evaluations are not clear, you can make mistakes in your judgment. If we draw limits, that will make our life easier, and the judgment will be objective, not just as per our subjective opinions. These lines will indicate the dispersion of data on a statistical basis and let us know when an abnormal situation occurs in production. If we add limit lines to our figure, we can obtain the graph that we can see here. So figure 7.3, in this figure we can see if there is any abnormality and take inappropriate actions, right? Here we can see that it's likely that we have something wrong here, we had something wrong here, and then we started to become within the control limits, the upper control limit and the lower control limit. It seems that we have hit the control limits again to the other side. So here we may get based on the average performance monitored daily or on a time scale. It seems in the beginning we had an issue with the average performance, daily average performance, and in the beginning in these 2 points. Then we became stable, and then we hit another issue again. But in terms of range, we are more or less within the stable. We are more or less within the control limits, so that we don't have that. So we have an issue with our average, mostly with our average, not within the dispersion or the range of data. So normally we will draw 3 lines. The first is the upper control limit, and the center line, and the lower control limits, via which we can judge the stability of our process.